Good morning, students. Myself, Kaushik Ghosh, your physical science teacher. This video lesson is for class 9. The chapter which we are going to discuss today is matter, structure and properties. Now, as this is a long chapter, I have divided this chapter into few modules. Today we will discuss the module 1, that is pressure of liquid and air. So let's start. Okay, so the first term what comes here is thrust. Now we will learn the definition of thrust. Thrust is the force exerted by a body normally to the surface on which it is kept. Normally means perpendicularly at an angle 90 degree. Now as you can see the diagram here, this book is kept on this table and the weight of the book which is acting downwards, that is 5 Newton, for example, it is given here. And as a result of this, the book also experiences a reaction force from the table which is equal to the weight of the book, that is 5 Newton. This is what we are getting from Newton's third law of motion. Now the thrust exerted by the book on the table will be equal to the weight of the book, that is 5 Newton. Another example, suppose if a body of mass 10 kilogram is kept on a ground, then the thrust exerted by that body on the ground will be equal to the weight of the body. And we know weight of a body is equal to mass into acceleration due to gravity. So I put the value of mass and acceleration due to gravity and we have got the result. So here 98 Newton is the thrust which is acting on the ground due to the book of mass 10 kilogram. Now we will define the term pressure. So pressure, the formula of pressure is force by area. Now from this formula, I can define the pressure here. See how. Now if I make the area 1, that is unit, so pressure is becoming equal with force. Thus pressure is defined as the force acting normally on unit area of the surface. At the same time, we have learned that the force which is acting normally on a surface is known as thrust. So pressure can be also defined as thrust by area. So it can be defined as the thrust acting on unit area of the surface. What is the unit of pressure in SI system of units? And we know that in SI system of unit, the unit of force is Newton and the unit of area is meter square. So the unit of pressure is Newton per meter square and also it is known as Pascal. Okay, now we will see few examples here. See, in this picture what you can see, we are cutting fruits with the help of a knife. Now if the knife is not sharp, if it is blunt, then we have to apply more force to cut the fruit. Also in this example you can see this one, this disposal van means this injection syringe. If the tip of this syringe is not sharp enough, then more force will be required to make it penetrate through the skin. Now here this vehicle which is moving over the sand, if the vehicle is unloaded, it is not loaded, then it will not stuck in the sand. But if the vehicle is loaded, the same vehicle, it gets stuck in the sand. Now from this what we understand is that if the area of cross section is more, then more force will be required to produce the required pressure to cut the vegetable. Here if the area of cross section is more, if that means if it is blunt, then more force will be required to have the required pressure to allow this syringe to penetrate through the skin. At the same time here what we can see, if the same area of cross section in these two diagrams, as we have taken the same vehicles here, their area of cross section of the wheels are same. But if less force is there, then pressure exerted by this car is less. But if more force, that means if its weight is more, then more pressure will be exerted by this vehicle on the sand. So from here, what we can understand is that pressure depends on two factors, that is force and area of cross section. And as we have seen from the previous formula, pressure equals to force by area of cross section, means pressure is directly proportional to the force and pressure is inversely proportional to the area of cross section. That means if the force increases by keeping the area of cross section constant, then pressure increases. And at the same time, if area of cross section increases keeping the force constant, then pressure decreases. Well, here I will show you the table where I have just out the dimensions and units of thrust and pressure. Let us see. So first here, this is the table. Now the quantity is thrust, whose dimension is this, it is same as the dimension of force, that is ml t to the power minus 2, and its CGS unit is dyne and its SI unit is Newton. So it is same as that of force. Now pressure equals to, we know, thrust by area, so this divided by L square, the dimension, so it will come as ml to the power minus 1 t to the power minus 2. CGS unit is dyne per centimeter square, SI unit is Newton per meter square or Pascal. Well, our next topic is pressure at a point in a liquid. So now I will show you how to find the pressure at a point inside a liquid. So for this, as you can see, we have taken a liquid here. Now this calculation is here. Okay, now see how we are doing this. So first, a cylindrical vessel is considered containing a liquid of density D. So the liquid here is of density D. Let S is a point at a depth h from the surface of the liquid. So the point S here is at a depth h from this free surface of the liquid. Now surrounding the point S inside the liquid, a small horizontal area A is considered here. A small horizontal area A is considered. Let we imagine a liquid column of area A up to the surface of the liquid in the vessel, means this cylinder. Here, the force exerted by the liquid on the area A is nothing but the weight of the liquid column of height h and base area A. Means the force which is acting on this area is actually the weight of the liquid which is here inside this. Now if I want to find the pressure at this point, means at S, so that will be what? Thrust by area. So thrust of the liquid on the area A divided by this area A. Now thrust means what? The weight of this liquid column here, whatever liquid is stored here inside, that weight of that liquid divided by this area. Now as we know, weight equals to mass into acceleration due to gravity, W equals to mg. There is also a relation between mass, density and volume. We know that density is equal to mass by volume. That means mass is equal to density into volume. So in place of W equals to mg, in place of m we will write volume of the liquid into density of the liquid, into, in place of g we will put g, that is acceleration due to gravity. So weight of the liquid column becomes volume of the liquid column into density of the liquid into acceleration due to gravity. Now divide by area was there, so it is here. So if the volume of the liquid column, how to find out this one? Now see, if A is the surface area here and h is the height of the cylinder, then the volume will be area into height, that is A into h. So it is written here A into h. D is the density of the liquid, so D, and G is the acceleration due to gravity, so AH into D into G. Divide by area A. So here A cancels out, so what remains is H D G. So the pressure is coming H into D into G. That means depth into density into acceleration due to gravity. Now suppose if the atmospheric pressure is P0, which is acting on the free surface of the liquid, means the atmosphere is giving pressure P0 on the surface of the liquid, then the total pressure here at depth h will be the atmospheric pressure plus pressure due to this liquid. So P0 plus HdG. Next, what is here? The factors which are affecting the pressure in a liquid. So from the formula we know P equals to H dg, where H stands for depth of the liquid column, D stands for density of the liquid, and G stands for acceleration due to gravity. So these are the three factors which are affecting the pressure in a liquid. Next, the characteristics of liquid pressure. First, see what is there. Pressure at a point inside a liquid at rest is equal in all directions. Means a liquid which is at rest, it will exert equal pressure in all directions. At all points on the same horizontal plane inside a liquid, upward, downward, and lateral pressure of the liquid are equal. Okay, upward means the pressure which is given in upward direction, downward means in the downward direction, and lateral means sidewise, means in the walls of the container. Pressure at a point inside a liquid depends on the depth of the liquid, that we have seen. It depends on the H, and it is directly proportional, means if depth increases, pressure also increases. Next, pressure at a point inside a liquid depends on the density of the liquid, and this is also directly proportional to the density, the pressure of the liquid. So if the density of the liquid increases, the pressure also increases. Next point, pressure at a point inside a liquid depends on the acceleration due to gravity at that place, that is the value of G. Pressure applied at any part of a confined liquid is transmitted equal in all directions, undiminished in magnitude, and that transmitted pressure acts normally on the surface of the containing vessel. This means that confined means stored, which is not flowing. So if you apply a pressure on a liquid which is in rest, then that pressure gets transmitted equally in all directions. Undiminished in magnitude means equally with the same magnitude in all directions, and that transmitted pressure acts normally on the surface of the containing vessel. Normally means perpendicularly, means the pressure which is transmitted and the pressure acts perpendicularly on the surface of the containing vessel. Next is siphon. What is siphon? You can see this diagram. Siphon is an arrangement used to transfer liquid from one vessel to other without disturbing the liquid. So from this vessel to this vessel, the liquid is being transferred without disturbing this liquid and without the presence of any external force. Its action depends on atmospheric pressure. So this siphon, this mechanism of siphon is basically dependent on the atmospheric pressure. It consists of an inverted U-tube. You can see this one. This is the inverted U-tube, completely filled with liquid. This is filled with liquid, and its shorter arm dips into the liquid to be transferred. So this is the shorter arm which is dipped into the liquid to be transferred. So this liquid will be transferred, while the longer arm is put in the vessel of the lower level. This is the longer arm. This is put in the vessel of the lower level with respect to the liquid to be transferred. Got it? So from where it will be transferred, there the shorter arm will be dipped, and where it will be transferred, there the longer arm will be dipped. Well, here I will try to explain you how does siphon work. Now see, this is the basic diagram which is given of working of a siphon. Now I have taken 2 points on the same horizontal plane on that connecting tube, one at A and another at B. Let the pressures at A be PA and at B be PB. Now what is the net pressure which is acting here? That will be the difference of the atmospheric pressure which is acting here and the pressure exerted by the liquid column of height H1. Similarly, the net pressure which will be acting at B, that will be the difference between the atmospheric pressure and the pressure exerted by the liquid column of height H2. So what is the pressure exerted by the liquid column of height H1? That is H1 into D into G, where D is the density of the liquid and G is the acceleration due to gravity. So similarly, the pressure exerted by the liquid column of height H2 is H2 into D into G. So if P0 is the atmospheric pressure, then the net pressure here will be P0 minus H1 dg, and here will be P0 minus H2 into d into g. Now as you can see, H2 is longer than H1. As H2 is longer than H1, that's why H2 into d into g, that value will be more than H1 into d into g. Now from this, if I take the difference of P0 minus these pressures, as P0 is same for both the points, so what I will get, P0 minus H1 dg, this factor you can see here, is greater than P0 minus H2 into dg. So I can say the pressure at point A is more than the pressure at point P. So there is the difference of pressure, and here is the higher pressure, and here is the low pressure. So the liquid will flow from a point A to the point B. Well, the next is liquid finds its own level everywhere. See, this is a property of the liquid. As you can see here, I have taken few tubes of different shapes and size which are connected to a common tube here. Okay, let me show you. Here, as you can see, this is the common tube with which these different shapes and size tubes are connected. Now if you pour water on any one of the tube, what you will observe is that in every tube liquid is rising up to the same level. Means irrespective of shape and size, the liquid has gone up to the same level. So that's why we say liquid finds its own level everywhere. Now the application of this property, the first one is the town's water supply is based on this application, and the second one is artesian well. Here is also the same property of liquid is used. Well, this is for the day. Go thoroughly through this chapter from your textbook. Have a look on this video lesson twice or thrice. I'll be back soon with the new modules. Till that time, stay home, stay safe. Take care.